All right. Hello, we are going to continue 5-1, operations with polynomials. Before, we talked about simplifying monomials, or at least simplifying single terms using the powers properties, the properties of powers. Today we will be looking at talking about the degrees of monomials as well as the degrees of polynomials. So we will define what that means, what degree means. Then we will look at simplifying polynomial expressions. So first, let's start with a couple of definitions. I believe we've already talked about these before as well, the degree. So let's talk about the degree of a monomial. The degree of a monomial is the sum of the powers on the variables in a monomial. So the sum of the powers on the variables in a monomial. A quick reminder about monomials. A monomial is a number, a variable, or the product of numbers and variables where there are no negative or fraction exponents. The exponents must be positive and they must be integers. I'm going to go ahead and write that down here as a stricter definition of what a monomial is. We had a rather loose definition before. So a monomial is a number, a variable, or the product of numbers and variables where the variables must have positive integer powers. This means that in a monomial, to be strictly defined as a monomial, the variable cannot appear in the denominator. It cannot appear in any type of root. It must have a positive integer exponent. So the degree of a monomial is the sum of the powers on the variables in a monomial. The degree of a polynomial remember that a polynomial simply means many terms. So the degree of a polynomial is going to be the highest degree of its monomials. So a polynomial is going to be several monomials that are being added together. Figure out the degrees of all of the monomials in a polynomial, and whichever one has the highest degree will be the degree of the polynomial. So the highest degree of its monomials. As an example, let's say that I have the polynomial 1/4 x to the 4th y cubed minus 8x to the 5th. First, I would ask the question, are each of these monomials? And the answer is yes. None of the variables are in the bottom of the fraction. Notice, though this has a fraction, the only thing in the bottom is the 4. That's fine. So none of the variables are in the bottom of a fraction. None of the variables are in roots, and none of them have negative or fraction exponents. They all have positive integer exponents. So if I ask what the degree of the first monomial is, it's the sum of the powers. So 4 plus 3, this first one has degree 7. The second one, x is the only variable, and it has the power 5, so this has degree 5. The degree of the polynomial would be 7 because that's the highest degree of its monomials. If I were to ask you about this expression, if I asked you what the degree was, you would say, well, it doesn't have a degree because it is not a polynomial. The square root of x is not a monomial, so this is not a polynomial. The same type of thing would be said about the expression x to the negative third plus 2x to the negative second plus 6, because these have negative exponents, and you cannot have negative exponents in a polynomial. Next, let's talk about simplifying polynomial expressions. There are a few things that we will talk about for simplifying polynomial expressions. Addition and subtraction is fairly easy. Adding and subtracting polynomial expressions simply means combine like terms. So if I were to have the polynomial 4x squared minus 5x plus 6, and I wanted to subtract the polynomial 2x squared plus 3x minus 1, I would just subtract the like terms. So 4x squared minus 2x squared is 2x squared. Negative 5x minus 3x goes further negative, so that's negative 8x. And then 6 minus negative 1 really means plus 1, so that's plus 7. So my answer would be 2x squared minus 8x plus 7. If I were to ask the question, are these parentheses doing anything? The answer is yes. The second parentheses are doing something, because I would have to distribute the negative here. If you wanted to see what this looked like without the parentheses, I could just drop the first set of parentheses. Then I would have to make sure I distribute the negative, so this becomes minus 2x squared minus 3x plus 1. And I would then be able to eliminate my parentheses, and then I would just combine my like terms. Gets me to the same spot. Adding is even easier. If I have 6x squared minus 7x plus 8, and I want to add 4x cubed minus 4x squared plus 9x minus 5. Well, in this case, as an addition problem, the parentheses are not doing anything. So I could just completely drop the parentheses and then look for my like terms to combine. If I look at this, I notice I only have one x cubed term, so I'm just going to put the positive 4x cubed first. Next, I have a 6x squared and a minus 4x squared, so that's a positive 2x squared. I have a negative 7x and a positive 9x, so that's a positive 2x. Then I have a positive 8 and a negative 5, so that's going to be plus 3. And there's my answer for adding those polynomials together. So adding and subtracting is fairly simple. It's just combining like terms. With multiplication, we are distributing. And this is something that we've covered before. FOIL, for instance, was an example of multiplying polynomials together. Strictly speaking, FOIL was multiplying two binomials together. But if we remember our definition of each term in the first gets distributed to each term in the second, then we can multiply any two polynomials together, as long as we remember that we are distributing each term in the first polynomial to each term in the second polynomial. Whether this is as simple as a monomial being multiplied with a polynomial, so multiplying means distribute. That could be as simple as, say, 3x times 2x squared minus 4x plus 6. I would then just distribute the one term in the first to each term in the second. Remember that when I multiply these terms together, I would be using my power properties. So if I have the same base, I can add the exponents together. So 3x times 2x squared, multiply the coefficients together, so 3 times 2 is 6. X times x squared means I add the exponents. I cannot see an exponent on this x, means it must have a 1, so 1 plus 2 is 3, so that's x to the third. 3x times the negative 4x gives me negative 12x squared. 3x times positive 6 plus 18x, there's my answer. No like terms to combine. This could, however, be as complicated as multiplying a quadratic, say x squared plus 4x plus 16, with some other polynomial, say x minus 4. I need to distribute every term in the first with every term in the second. So distribute the x squared. X squared times x is x cubed. X squared times negative 4 minus 4x squared. Next, distribute the positive 4x. 4x times x plus 4x squared. 4x times negative 4 is minus 16x. Next, distribute the positive 16. So I've got plus 16x, and then 16 times negative 4, minus 64. Next, I look for like terms to combine, and as I look, I've got a negative 4x squared and a positive 4x squared. Those will cancel out. I've got a negative 16x plus 16x. Those will cancel out. All that's left is the x cubed and the minus 64. So my final answer is just x cubed minus 64.